In this intermediate topics video of the Integrated Data Viewer tutorial series, we're going to continue our discussion of isentropic analysis and plot scalar quantities on isentropic surfaces. I think I'll actually make one more video on isentropic analysis after this to address the use of isentropes in cross-section figures. We're going to start by plotting moisture on an isentropic surface. You know I like the NAM, so we'll pick a NAM dataset, and we go to the 3D grid. Under derived parameters, there's a variable called potential temperature isosurface scalar analysis. So we can use that. We'll just use one time step again. I like using the color shaded image contour, but we actually have to pick our moisture variable. So we go back into our data set and it has to be under the 3D parameters. And we have an option for relative humidity. It's one way of plotting moisture and it's a pretty simple one. And we need to make sure that we only use the same time step as we use for the potential temperature isosurface. So this plot was pretty easy to make. Again, you can rotate it. You can actually see the distribution of relative humidity on the surface. Those areas with really high relative humidity, the reds, according to the color bar, those are 99% relative humidity, which means that there's probably a cloud there. If you add this to an analysis that includes wind, you can see the flow of moisture. Potential vorticity is frequently plotted on isentropic surfaces. In fact, potential vorticity calculated relative to potential temperature is known as isentropic potential vorticity, or IPV. We actually have a sample bundle that's designed to showcase this particular quantity. If you look under NAM 211 samples, you see this isentropic potential vorticity bundle. You click on that, and just like always, there's a flurry of windows and the bundle's open. As you can see, there are a few windows here. One of the windows shows our isentropic surface, and you'll notice that it only takes up half of our display area. That's because at a certain point, its height is higher than the top of our display area. You can also see that we have these lines plotted in the middle. This lets us see our cross-section in our main window. We also have the cross-section in a separate window. We'll go for more detail of how to make displays like this in the next episode. Because this shows wind speed, it's nice to use a color bar that changes colors at 0. This way we can see which wind is coming towards the viewer and which is going into the screen. Now we also have this other window that's something that we haven't talked about before. This is a display of a probe. Now you'll notice we have height on the y-axis and time on the x-axis. You can change which point the time series is shown for by moving this little red rectangle. The main difference between this and a cross-section is that this is one point plotted over time rather than one time plotted at many points. As always, if you have any questions, please visit our website at unidata.ucar.edu or email us at support-idv@unidata.ucar.edu. Keep an eye out for the next episode when we'll wrap up our discussion of isentropic analysis.